Hi guys, this time I would like to speak about particle velocity, acceleration and speed. Let's create a new scene by going to File menu, New Scene, and let's create a polygon sphere. So if we would animate the sphere moving along positive x axis, let's on a frame number 1 we keyframe translate x, move the time slider to frame 24 and type 24, keyframe it there, open animation graph editor and set the F curve to linear. If we take a look at the channel box at the translation value, we would be able to see the numbers for the translate x attribute constantly changing. And if we would take a position of the of the sphere at the current frame, let's say frame number 14, and if we subtract from a current position of this sphere on a previous frame, then we would be able to get a distance the sphere travels in one single frame. So let's say that the sphere makes 1 unit in one frame. We know that there are 24 frames in 1 second. If the sphere travels 1 unit per frame, and there are 24 frames per second, that we would say the sphere speed is 1 unit multiplied by 24 frames by 1 second, which would be 24 units per second. I hope that's pretty clear. Let's go to File, New Scene, and let's create a particle emitter. Option box, and as emitter type, let's choose directional. Rate could be anything as long as it's higher than 1. And let's set the speed of the emission is equal to 10. And then we would say that since the directional, let's say direction along x is 1, along y and z it's 0. Let's create and let's play back. And we can see there's a stream of particles moving along x positive axis. Let's select the particles, open an attribute editor. Under the particle shape, scroll to the top of the attribute editor, find the field called max count, maximum count, and let's type 1. By typing this number, we tell in Maya that only one particle can coexist in any particular time. So we only deal with one particle. Under the particle render type, let's choose spheres so we can clearly see it. Let's set the last frame of animation to 400. Let's rewind back to the first frame. Play back. One sphere, one particle is moving along x positive direction. So in order to be able to calculate the distance the particle travels in one frame, we need apparently the current particle position, which is already given us as a position attribute, position per particle attribute, and we also need to know the particle previous position. So let's create, since the position attribute already existent, let's change the particle render type from a sphere to numeric. Click current render type. Default particle ID, change it to position. hit enter, and now we're able to see the coordinates of the particle at the current frame. Go to per particle array attributes and click General button. By doing so, we open Add Attribute Add Attribute dialog box. Choose per particle. Data type as a vector, since we're about to create an attribute that will store previous particle position. And the name for the attribute is a previous underscore position. Click Add. Close. We know that there are three types of expression that can be created for the particles. First is a creation expression that only runs on the first frame of the simulation. Two others called runtime particle expressions before dynamics and after. The difference is very subtle. Let's create a creation expression. Right click on just created per particle attribute that is called previous position. Creation expression. Copy the name of the attribute and paste it into expression field. Equal sign and then position. Create. So when we hit create button, what happened, we created expression that will be run only once at the first frame of the simulation. The current position of the particles, which is on the frame number 1, will be read first, and then a value of it assigned to the just created custom per particle attribute that we call previous position. Close, rewind. Now, right click on the same previous position attribute, and this time choose runtime after dynamic expression. Since we didn't define anything there yet, the expression field is empty. First, declare the vector data type, vector, variable, current underscore position. And once again, we read the current particle position into this variable. Create. Vector current position, create. The second variable that we would like to define is called previous position. And it's equal to a value that we stored using a creation expression. And it was filled with the particle position and it's a frame it was burned. So we have two variables, each storing its own variable data. One stores the information where the particle is on the current position. Another variable stores the information where the particle was a frame before, on the previous frame. So in order to find out or calculate the distance the particle traveled in one single frame, since we're dealing with the current frame and previous frame, we declare a third variable and we call it travel distance. And it's equal to current position, as you probably already guessed, minus previous position. And click Edit. So now we know how much the particle traveled in one single frame. The result of the simplest calculation is nothing but distance. In order to turn a distance into the speed, we need to bring a time factor. Since when we drive a car, it's always measured distance in time, 60 miles per hour. So if you drive a car 1 mile per minute, that means the car has been driven 1 mile per minute multiplied by 60 minutes in 1 hour, 60 miles per hour. The very same math we would be using here, with only one difference, that instead of hours, we will be using seconds. And instead of minutes that been used to calculate speed of the car per hour, we would be using frames. And we know that in Maya, if you're working in film, then it's 24 frames per second. So we, in order to calculate the speed, we would use, let's call calculated speed is equal to travel distance multiplied by 24, and click edit. So now let's play back. Nothing should change, since all we did just read the data and calculate the data. So now let's click General tab and add another attribute, and we call it Info. So Info for ourselves. We call it per particle. We choose per particle again, and data type is a vector because we will be storing 3 numbers into this attribute, and click Add. Close. Find this attribute that we just created in the attribute editor. Sometimes you need to reselect the particle for the attribute editor to pick up the changes. And here I see the new info attribute. Right click on this attribute. Say runtime expression after dynamics. Copy this attribute name and paste it into expression field, and assign calculated speed as a vector. We calculated it into this info field. So click edit. Last thing, just to make sure we don't forget to do, as you recall, we created a creation expression and we filled a previous position attribute with the current position value. It happened only once on the first frame of the simulation. But since this expression will be run again and again on each frame, and each frame the time slider will be advancing forward, we need to make sure that the previous position attribute is being updated with the frame that we live in. So copy the let's say previous position, name of the variable, put it on the very last line of the expression, equal to position. So we just to make sure that the previous position attribute is updated on every frame. Edit and close. So now if I play back, we're still displaying the position attributes as a numeric data type. Let's change it from a position to info. What we do now, we're displaying the speed of the particle that we calculated using runtime expression. Once again, I would like to recall what we just did. We first read current particle position, this particular frame, which is in my case frame number 14. Then we retrieved a previous particle position that we stored in our own custom previous position vector attribute. Then we subtracted a previous position from a current position attribute. By doing so, we calculated how much the particle traveled in one single frame. Result was a distance attribute, the distance value. In order to turn a distance into the speed, we had to multiply this number by time factor. Since we're working inside of Maya, where things been represented in seconds, and if you're working in film, it's 24 frames per second. If you're working for TV, it's a 30, or in PAL 25, depending on what you would like to use. Feel free to type that number there. By multiplying the distance the particle traveled in one single frame by the number of the frames per second, we're getting the calculated speed variable value. And since we never translated, and since we always stayed in a vector data type, the result we got is a vector. So now, since we, aside from the previous position attribute, we also declare info attribute. Let's just to make sure that our info, yes, our info attribute is being fed with the calculated speed. So what we see in the viewport is the speed of the particle along its 3 axes. So right now it's, let's say, in my case, 180, 190, 120, 210. Okay. Just to make sure everything is correct. Okay, so now let's change info to velocity. And the velocity shows us a number that's slightly different. Sorry for this little tweak here. And the last line is I was describing what I had to do is to update the previous position attribute with the position of the particle at the current frame, just to make sure that this attribute is always updated. But as I was speaking, I typed quite different line into it, producing a bug in the expression. I fixed that right now. And as you can see that I'm displaying the value in numeric field for the info attribute, which we calculated here. Once again, we subtracted previous position from a current position of the particle. Then we'll multiply it by 24 frames per second. By doing so, we calculated a vector speed of the particle. And we displaying this calculation using info per particle attribute here, and it shows us that the particle moves along x-axis with the speed of 10 units per second and 0 units per second along y-axis, and a 0 units per frame along z-axis, which is completely true because the particle moves along x-axis only. So now let's change attribute name from info that we display in the viewport to velocity. Hit enter, and as you can see, it's exactly same value. What we just did by calculating the speed of the particle, we calculated the velocity. So the formula, this formula here that we type into the runtime expression is nothing else but formula to calculate the particle velocity, which is turned to be nothing but the distance the particle moves in one single frame multiplied by time factor, which is a 24 frames per second in Maya. And the reason we can't really say it's a speed, because speed is usually represented as a float number. The only difference between velocity speed, or speed that we calculated, and real speed is that the speed is it represented as a distance of the particle makes in travels in 1 second along all three axes combined. That's a pure speed of the particle, meaning if let's say if I create a sphere just to illustrate it. Right now the particle moves along one axis only, positive x. That's why we've got kind of, first number that represent x-axis representing like a pure speed. But if the particle would move along all three axes, then the real speed would be to a magnitude of all three axes, meaning like if the particle would move from a center or the world origin diagonally along the x and z axis, then the distance it would travel along this diagonal line here, right, would be longer than the distance that we would project on the x-axis and on the z-axis right here, right? So the coordinates that would fall on the z-axis here and on the x-axis here would be this distance here, and this distance here would be shorter than the diagonal line itself, the path along which the sphere would be moving. So the pure representation of the speed has got everything to do with this path that the sphere is traveling, while we calculated velocity, and the velocity is the speed that measures along x, z, and y-axis individually. So that's really the only difference. What makes a real speed that we deal every day driving a car, and the velocity number that been represented in the particle attribute tab. Once again, in order to calculate the velocity, we first read the particle position on a current frame. We used a particle position on a previous frame. We subtracted a previous particle position from a current frame. By doing so, we calculated the distance in units the particle traveled along x, z, and y-axis independently. And then in order to make that distance a speed, we multiply it by 24 frames, which is equal to 1 second. By doing so, we represented a speed of the particle in 1 second in world of Maya. And by doing so, we calculated a particle velocity. So now it's quite clear that every time we would like to look for the velocity, that's the type of calculation we would like to make. So next topic is about acceleration. Acceleration apparently is the change of speed. So if our particle moves with the consistent speed, which is happening right here, then the acceleration of the particle is probably 0. Acceleration. Let's type acceleration into the field, rewind to the first frame, play back. Yes, it shows us that the particle acceleration is 0. That means that the particle is not changing the speed. Acceleration of 0 does not mean the particle is not moving. It means only that the particle is not gaining any speed and it's not losing any speed. The speed remains to be consistent. So in order to calculate the acceleration, we need to know what speed of the particle at the current frame and what the particle speed or what speed the particle had in the previous frame, just like with the position. We need current particle speed and previous particle speed. So for this purpose, let's create a custom per particle attribute that we called previous velocity. We define data type as a vector. We don't forget to pick per particle, and let's call previous velocity and click add and close. So now just refresh dialog box, the attribute editor, find previous velocity, right click, creation expression, copy and paste the name attribute in the expression editor. And just like we did with the position by applying it to previous position attribute using the creation expression that runs only once at the first frame of simulation, we did this exactly same thing with the velocity. We assign current velocity to previous velocity. And when I say current velocity, I'm talking about the velocity attribute that already predefined with every particle when you create it by Maya. Okay, so now let's go to a runtime before after dynamics expression. And here we, once again, to refresh our memory, first we created a vector variable that stores or reads current position of the particle. Then we created a variable that would capture the previous particle position into the vector data type variable. And this third line, let's type vector data type $, indicating that we're about to create a particle, variable vector data type, and we call it current velocity is equal to velocity, semicolon to close the line. And then another variable is a previous velocity is equal to previous, I copy pasted the name of the attribute so I'm not making a typo while recording this. Edit. So we got those two lines of expression that deals with the velocity. So here the third line that I would like to specify dedicated to the velocity is to calculate the difference. So let's say difference in velocity, and we're talking about difference in velocity that happen in one frame, and we take a current velocity and subtract previous velocity. Edit. Okay. And once again, we're dealing here with everything that happens in one frame interval. In order to make it 1 second, we need to multiply it by 24. No, let's do it on another line, because otherwise we have to change the name of the variable because we say difference in velocity. Okay, so now the third vector variable we call calculated acceleration is equal to difference in velocity, which is actually multiplied by 24. Edit. So just to clarify a few things here is that we took a current velocity, which is the speed, as we already learned from a previous few lines, And then we read stored previous velocity into the previous velocity vector variable. Then we subtract a previous velocity from a current velocity. And then since we're working with the frames per second, we need to multiply it by 24. So if by subtracting previous velocity from a current velocity, or by saying by other words, if we subtract previous speed from current speed and the difference is 0, that means the speed is exactly the same. So if the particle moves right now 5 miles per hour and the speed of particle in previous frame was 5 miles per hour, that means there's a 0 difference, meaning there's no acceleration. 0 value in acceleration, in our case calculated acceleration, means the particle moves with the consistent speed. Before we close this expression, let's not forget to update previous velocity attribute, this particular attribute, previous velocity attribute, with the velocity value that we deal on the current frame velocity, and click edit. So now first the value has been read, calculation takes place. Before the expression closes and might proceed to the next frame, both attribute previous position and previous velocity attributes are updated with the current value. So I don't remember if we created an acceleration info. Okay, so let's feed this time, or let's create a general, and we call it per particle array vector, and we call it calculated acceleration. Calculated acceleration, add, and let's just for fun a calculated velocity as well. Add. Just to make sure that attribute editor is refreshed, I need to deselect and select particle, so the user interface sometimes is not updated real time. And here in attribute editor, I say right click, calculated acceleration, runtime after dynamics. I copy the name of the attribute that we just created, calculated acceleration, and I equal to we found it calculated speed and calculated acceleration variable here, and I assign it to this attribute. And I also would like to assign calculated speed, which actually turned to be a velocity, into the attribute we just created, which call calculated velocity. Copy. I'm copy and pasting those attributes so I minimize the chance for a typo, so important while recording the video. Okay, and make sure you type those assignments before the last 2 lines of the code that assign update the data. Okay, so edit. Okay, and just to make sure, rewind to the beginning, play back. So right now we're displaying acceleration that is being made by or calculated by Maya. We have our own attribute, and it's called calculate acceleration, and then the one that we calculated ourselves, as you can see, it's exactly the same. Let's display factory velocity attribute. It shows us velocity of the particle that as defined by my velocity attribute is a 10, 0, 0. And if we would like to see the result of the velocity we calculated, velocity, it's also the same. And I would save this file for you to play later. And I say calculated velocity and acceleration. Okay, and now before we finish this portion of the class, I would like to take a look and talk about the attribute that we find under the emitter, and this attribute is called speed. So if we zero speed of the emitter and we play back, we see that the particle is not moving. The speed attribute that we see and find under the emitter tab is the only time when we were given an option to move the particle with assigning it a speed. What that means is that if, let's say, I specify a number of 10 as a speed number for the particle, at the frame the particle is born or created, the particle already moves with the speed of 10. So meaning there would be no acceleration preceding the first frame of the particle life. Meaning the particle accelerated to the speed of 10 at the time it is created, which is different from a situation if you would be modifying the speed of the particle in any other way than using emitter speed attribute. So for example, if I say particle, create particle tool, right? And by clicking anywhere in the screen or on a plane, I would create a single particle. That particle has got nothing to do with the particle where we're dealing till now. It's a brand new particle system, completely independent. And let's change the, let's say, to the sphere. So this is a particle that I just created by choosing the particle tool and placing it on a 2D plane or on a XZ plane. So if I play back, the first particle is moving just like it used to be, but the new particle is not moving because it's not connected to any emitter. There's no speed that emitted into this particle. So if I would go ahead, right click on the velocity attribute of this new particle, copy the name of the attribute velocity, and I say equal to, and I say 5 along the x and 0, 0 along the x along the y and z axis. As we just discussed, the velocity is nothing else but the speed the particle travels along the each axis. So since I zero y and z, this particle will be moving with the speed of 5 along x axis. So let's see if it's true. It is moving, so you can see that it is possible to modify the speed or move the particle dialing the expression numbers straight into the velocity field. So this particle, the first particle, shows us that it moves 10 units per second as a result of emitting 10 units using emitter speed attribute. So if we select this second particle that we created and we drive with the expression, instead of, let's say, particle velocity is equal to 5, let's say to 10, and hit edit, if I rewind to the beginning and play back, this two particle would be moving exactly same speed. So by saying so, we can assume that the attribute, the speed attribute of the emitter, and the number we enter into the speed field of the emitter speed attribute is equal to the same action if we would just select the particle and right click on its velocity and say creation expression, and this number that you type into the speed attribute of the emitter, you type straight into this field. So now instead of like using let's delete this expression, delete, okay? I rewind back to the beginning, I play back, particle is not moving again because we just deleted the expression. So instead of like dialing the velocity number into the expression, I select this new particle and I go to field and say a uniform field. And before I hit the playback button, I change the magnitude, I leave magnitude at 5, but I put attenuation to 0, direction 1 along the positive x, and 0, 0 along other 2. So if you rewind to the beginning and hit playback, I can see that the particle is moving. But what becomes evident straight from the beginning is that the particle is not moving with the consistent speed as the first particle, meaning like this particle speed is not consistent. It looks like it's increasing the speed every time. Once again, there's two differences between the way we move this particle. First particle is being moved because we use a speed attribute of the emitter, which we learned already is the same as the typing this number into the velocity field or as a velocity attribute of the particle. And we learned that velocity attribute of the particle is nothing else but the speed of the particle along x, y, z axis independently. This new particle is not driven by the speed attribute of the emitter. That means there's no velocity is being affected of this particle directly. What is being the particle is being moved with inconsistent speed. The speed is constantly changing and is increasing with every frame. That makes us believe that this most likely acceleration of the particle is changing. So let's select the first particle, and instead of calculated velocity, let's type acceleration, or calculated acceleration. It really does not matter. And the first particle, as we remember, has got 0 acceleration number, meaning like it's not changing any speed. Calculated acceleration will show you the exactly same number because, as we remember, we put this together exactly the way it's been calculated. The second particle here, let's change it from a sphere to be numeric and calculated render type from particle ID to acceleration. Enter. And we can see that the particles got consistent number of the acceleration is equal to 5. That means that this particle, as we remember, this particle will change its speed every second by this number in x-axis, meaning like this particular particle will gain 5 units per second at every second of its simulation, meaning like if at frame number 24 this particle speed is 5 units per second, on frame 48, which is 24 frames after or 1 second after, this particle speed will be already 10 units per second. In order to see this speed, we can calculate this speed by using magnitude of velocity, or we just can go ahead and type velocity, which will give you the speed of the particle pretty accurately, especially if the particle moves along one axis only, since there will be no diagonal lines or vectors projected to other axes. So we can see that the particle speed is changing. The acceleration value is not 0, it's different from 0. That means the speed is changing. So the main reason why we're talking about acceleration versus velocity versus speed, or how much the difference between velocity and the speed, is just to learn that every time we use a emitter attribute speed to affect the particle motion, we give the particle consistent motion, consistent speed that never changes. From the first frame of the particle simulation, the particle is given the same speed as you specified in a speed attribute of the emitter. This number is actually being put straight into the velocity of the particle, depending what options are chosen for the direction of the speed or direction of the particle travel. If the particle is moved with the fields, then instead of the velocity being affected directly, instead of the particle velocity, the particle acceleration is being affected. And acceleration, as we already know, is the change of speed that will happen to the particle at every second or every 24 frames. Okay, so the last note to realize is that, and it should be mentioned, is that if I create a particle tool and I place a particle here, right? If I change, if I create expression, let's say right click on velocity and say create expression, particle velocity is equal to, and once again, just like last time, and let's say it's a 5, 0, 0, and I hit edit, create, close, and I rewind, and I play back, and I change the points to numeric current type, and I type acceleration, like this, right? So you see acceleration 0, particle moves with the same speed that we specified under the expression, and the velocity, if I would like to, instead of numeric streaks, right? And you can see there's a velocity in this particle, meaning if you start to emit a velocity into the fluids later, which will be evident later in later classes, how we emit the velocity into the fluids, then it kind of becomes important that we make sure that this particle does have a velocity. So we manipulate this particle velocity directly with the expression, and the particle velocity data is valid and applicable to the fluids to be emitted to, right? So if I create an expression, delete this expression. Okay, so now instead of drive or move the particle, all we do every time we type number into the velocity field, or we modify the velocity attribute using expression, every time we modify velocity or the acceleration attribute, we actually all we do is change in particle position in 3D space. So let's not be too focused about the velocity versus acceleration. End goal is to move the particle into the place we would like, right? So that's the main motive by affecting acceleration and the velocity. Acceleration and velocity is just a tool to move the particle in 3D space. So now let's right click on the acceleration and say creation expression, and this time we type particle acceleration is equal to, and we say 5, 0, 0. So let's recall again. Every time we change acceleration of the particle, we're saying that this particle will gain speed 5 units per second in 1 second. Every second, this particle speed will be increased by 5 units per second. Different in comparing to velocity. Every time we deal in, instead of acceleration and velocity, we're saying this particle will move 5 units per frame, period. No more, no less. And it will have no time to accelerate or decelerate. It will start immediately. So I play back this. Once again, I'm affecting particle acceleration with the creation expression, meaning this particle will gain 5 units per frame speed at every frame. And you know what strange thing that I noticed is that in order for this acceleration to work expression, you need to put it under the runtime after dynamics. Even here it's not really working. By some reason you need to specify some kind of value, I believe. Yeah, unfortunately, you need to give it some kind of speed at the beginning in order for acceleration to pick up. It by some reason it can't really start with the zero value to it. And the creation expression is not really friendly in this regard. So let's say not that it's a kind of often scenario where you start dealing with the particle at the frame of creation immediately with affecting the acceleration attribute. Is quite unusual, but for purpose of understanding it, I still don't see it. Here's the particle. Even after I delete the here's the particle. Okay, so I go here under the acceleration, create expression, and copy paste, and I say acceleration is equal to 5, 0, 0, and then I close with this semicolon and rewind to the beginning and play back, and it's not moving. Very interesting. Even after I select this and assign it to as a runtime expression, and it is moving. So as I just mentioned, it's kind of easy to forget what expression it needs to start evaluating. Apparently creation expression is not really kicking from the beginning, so by some reason it requires runtime expression to function. So we can see here that if I select this particle and I go to Window, General Editor, and Component Editor, then the velocity value is changing. So it meaning like velocity is being calculated for this particle. So if we drive particle motion with the expression that affects particle acceleration, or particle velocity. Both acceleration and velocity for the particle is being calculated properly, meaning we later can reuse or use this particle with the fluid simulation just when we emit the velocity. But it would be completely different story if I would be driving particle, if I would modify third attribute, which is a position. So let's take a look. Creation, expression for the position. And I say on the first frame of simulation, particle position is the world origin, which I type 0, 0, 0 and say create. I copy this line, I go to runtime before dynamics, and I say particle position is equal to, instead of that, I would say, first of all, I read into vector, vector data type variable, and I say pose, and I say position, right? Position. We already learned how to do that. And then I create a float, and I say just $x pose, right? And I say x position float is equal to whatever this particle is at the position x plus, let's say, 0.2, like this, right? And then I use this float variable to modify the x position of the particle at every frame. So x position of the particle, x coordinate of the particle will be increased by 0.2 at every frame. Close, play back, and yes, we can see that our particle is moving. Not the particle system is moving. See, the translation value for the entire particle system remains to be 0, meaning like we're affecting per particle attributes, just like velocity and such. But take a look what happens to the particle particle attributes in the per particle attributes. You can see that the yes, indeed, the per particle attributes are changing for the position, right? But none is changing for the velocity or acceleration. As you can see, like the way the component editor works, that it filters out most of the attributes that's got 0 value to it. So for example, if the velocity are zeros, those velocity attributes not even displayed. But since the component editor, is sometimes so smart that it filters out so many attributes, even if those are zeros, sometimes I want to see them anyway, I can switch to numeric once again, and here type velocity. And as you can see, that velocity attribute is 0 even while the particle is moving. That means that this particle is useless in this form for the fluid as a source of the velocity emission. So that's something that we need to keep in mind, is that while expression offer quite a powerful way to affect a particle position, acceleration, and velocity, some of the hidden caveats there, and we just need to make sure that we remember about them. And one of the most frustrating surprises is that the effect in particle position on a per particle basis is not resulted to velocity calculation. Not a big deal for those, for us really, because we know how to calculate our own velocity now. And once again, let me remind you at the end of this class is that velocity has been calculated by taking a current position, subtracting previous position from a previous frame, and multiplying by the time factor, which is in my 24 frames per second. Acceleration is calculated in a very similar fashion. You take a current speed, which is can be calculated from taking a magnitude of the velocity, or you can just take a magnitude. You can take a velocity, current velocity, and subtract a velocity from a previous frame, and then you multiply it by 24. The reason why I would want to use a vector velocity, the current velocity, and subtract a vector previous velocity is because this simple math results to the vector that I can use as a multiplier to 24, producing the vector once again, because my acceleration is nothing but the vector. If you would like to calculate a real pure speed, you need to take a velocity vector stored in a per particle attribute as a per particle attribute in an attribute editor as a velocity attribute, and use a magnitude function, which is mag, and that would give us a pure speed or length of the vector itself. And that's principally it. But it's not really important what exactly we treat as a speed. What important is to realize is that we're able to affect particle position by manipulating particle velocity attribute through the expression, or particle acceleration through the expression. And then by modifying a particle velocity using a particle emitter speed attribute, we affect nothing but the particle velocity. By using a field from a field menu, such as a gravity, uniform, turbulence, radial, and vortex, and such similar, we always modify acceleration attribute of the particle, and acceleration attribute of the particle is a number that shows how much the particle will lose or gain speed at every second of a simulation. I hope that was clear enough. I think it's extremely important for everyone to not just to get familiar with the concept of acceleration, velocity, position, and the speed. It's extremely important to make it as a second nature. There are no other attributes as important as those three. And I welcome everyone to dedicate as much time as it takes to get yourself comfortable and knowledgeable with those quite simple but yet extremely useful concepts. I see you next time in next class. Thank you. Bye.